This is quite a historical tape recorder. This is the EMI BTR-1, which stands for the British Tape Recorder 1. Originally, the BBC and other broadcasting companies would have been using machines such as the Blacknophone and Marconi style, and during the transition between the steel tape recorders and the plastic tape and paper tape, they did use a few magnetophones, but the magnetophones were dismantled, backwards engineered, and then companies such as EMI brought out large recorders like this one. I have actually seen more magnetophones and tonschreibers come up for sale than these machines. In fact, I've had the opportunity to buy over 4 tonschreibers and about 3 or 4 AEG K4s and 1 AEG K1. But this machine, I got it imported from New Zealand. There didn't seem to be one in the UK. I had a chance of importing one from America and one from Switzerland, but both of the sellers wanted too much money for them. I luckily got this one relatively cheap, and the shipping wasn't too extortionate, and now the machine is back here a month later, ready to be restored. There are echoes of the magnetophones on this machine. For example, the large Headlock, which has the tape oxide out. This machine has a mechanical lever here which releases the felt pads and also brings the tape away from their heads, probably used for when doing high-speed spooling. And then we've got a very large hum shield here to prevent any noise being picked up by the heads. The recorder used large powerful oscillators to create the AC biasing for the tape. And on the BTR2s, the KT66s used to blow quite frequently or wear out very quickly. I'm not quite sure what machine this is using for the arrays, but they've fitted this onto the machine, which has an on-off position. When you turn it into the on position, a permanent magnet at the front of here pops out, so when you fast wind or fast forward, it would wipe the tape. This may be to enhance the life of the bias oscillator's valves. Underneath the machine, very much like the BTR2s, you've got the 2 doors, but instead of them handles opening the door by turning them 90 degrees, you've got a press button which opens up one door, and then a release latch on the second door. And here we have the cables and the valve amplifiers. All of these units are held in with screws. You've got your mains leads and you've got your data cables, all of which can be disconnected. The units can be taken out, and because they've got the flexible cables on the front of the machine, you can then work on the unit, repair it whilst testing it at the same time. The machine has a built-in test unit or voltage selector here. We've got low and high on the scale with a white section in the centre of the scale to indicate a good signal or good test. You pull out your PO box connector here, and you insert it into different parts of the recorder to check to see whether or not things are doing what they should be doing. The main front panel is quite interesting, where you've got your spool control with your variable speed control, record with a release lever, replay and stop. The unusual thing about this machine is the scale on the meter. Most meters are -20 to +3 dBs. This machine doesn't have any minus numbers at all. It goes from 0, which is the first mark there, to +20 decibels. The recorder has been modified. We've got a capstan motor shut off here, which is damaged. We've got a real size selector down here. That's been added. But all the rest of it is as it should be. With the back of the machine removed, you can see some other things that you don't see on practically any tape recorder. For example, these here are the shafts down to the main motors. The capstan motor and the real motors were all located in the bottom of the machine. This one's been modified at some time, probably to reduce the woe and flutter caused by the long shaft. But all the motors were kept in the bottom of the machine. It was believed that this would bring down any kind of disturbance recording onto the tape. As we can see here, the large valves here, I can see 2 KT66s in there, so it's a similar style setup to the BTR2. Everything inside here is vast amounts of space, empty space inside this recorder, along with cobwebs. All the machine's tape deck is all mechanical, and we've got little cables here which operate remote sort of braking systems and pinch roller systems and stuff like that, unlike the later BTR-2, which was all operated by solenoids. This interesting compartment down here contains the mains lead. It's not got a UK plug in it because, as mentioned, this one's come back from New Zealand. Inside the machine we can see more of these pipes, or a little bit like a bicycle brake cable, which operates the main brakes and the pinch roller. Over the far end there we can see only just a second flywheel. This is attached to a roller on the top tape deck, and this is designed to add suppression to the whirl and flutter of the machine. We then got the main capstan, which should be down at the bottom of the machine. Got another flywheel there. These are obviously the shafts to the two reel tables. For instance, if you turn one, we can see that the tape and everything, all the path and everything underneath and how it moves. And those shafts then go down to the bottom of the machine. The head block on this machine is massive, and inside the heads are very large too. Some of the machines have large head blocks but have small heads housed in many shields, but this one, these are actually the size of the heads. Obviously the heads, there are smaller heads inside the machine, but that is basically the physical size of the heads. Undoing these two screws, and out comes the head block. Gives you some sort of an idea there. Now, this is another early thing. This erase head is made out of steel. I didn't learn until till recently that the reason why they changed these to ferrite cores, for ferrite heads, was because that the metal head's frequency responses can't go as high. So the erase oscillations on these are, in comparison to later tape recorders, quite low, where the modern sort of like Akai tape recorder or TAC recorder will be around about 150 kHz. This would probably be less than 100 kHz due to the fact that the head couldn't handle those kind of frequencies. Here is a closer look at the erase mechanism. We have here a permanent magnet, which if you turn the control knob, moves it in and out. Now, I'm not quite sure what this part is for. I mean, you've got your space here for putting your tape into, but I don't know what this hole's for. Something went in there and clicked into place. I read a small article on the internet about these machines. They didn't actually have a facility for splicing, because this machine would have originally run at 30 inches a second. The splicing could be very crude. This large roller here, which there should be one on the other side, which has been modified, with the tension arm here missing a roller and a cap. This has a neon light underneath it. When the tape turns, it causes a strobe effect, and the engineer could look at that and see whether or not the dots appeared to be standing still. If they were standing still, or appeared to be standing still, that meant the machine was running at the right speed. If the dots were wobbling left to right, or they were sort of chasing or moving, then the engineer knew that there was a problem with the tape deck. Either it had too much whirl and flutter, or the machine was losing speed for some reason. The recorder hasn't yet been powered on, and it will be some time before I even attempt that. Some components do look like as if they're missing from the inside on the power amplifier, but once the machine is up and running, there will be another video made